When solving linear formulas, we can solve them using the same steps we used when solving linear equations in one variable. So we are going to use the exact same steps that we have had in the earlier segments of solving equations. The main thing is that we're going to have several different variables involved in the problem, and they're going to tell us which variable out of all of those that we're supposed to solve for. Now, solving for a specified variable means that we want that variable on a side by itself equal to an expression that does not have that variable in it. So we need to watch for both things. Now, the key to this is to realize that you're treating the specified variable as your variable, and all of the other letters in there you want to move to the other side using the appropriate steps, and also paying attention to only combining terms that are like terms when you're moving terms to each side. So let's look through the steps first, and then we'll do an example. So for solving our linear formulas, we want to first remove all fractions and parentheses, just like we did when we were solving linear equations. Remember, to remove the fractions, we'll multiply both sides of the equation by the lowest common denominator over 1. And we can do that because we have an equal sign, and we have a left side and a right side to be fair to. And then we also want to remove our parentheses. In step 2, we'll get all our terms with our specified variable on one side of the equation. So we want to make sure to rearrange the terms so that all the terms that have the variable in it that we're supposed to solve for are on one side, and get all the terms without the specified variable to the other side. And remember, to move full terms, you do the opposite operation of addition or subtraction to move it to the other side. And then finally, we want to divide both sides by the coefficient in front of the specified variable. Now, with one variable, a lot of times when we said the word coefficient, we talked about just the numerical coefficient. But really, the wording of the coefficient means all of the factors that are multiplied to that specified variable. So let's take these steps to this example and see how they apply to solving this problem. Capital R is equal to xy over 4pq, and solving it for q. Well, our first step again is that we want to remove all fractions and parentheses. I don't have parentheses here, but I do have a fraction bar, and the denominator of the fraction is 4pq. So to remove the fraction, I want to multiply both sides by 4pq over 1. Because what I do new to one side of an equation, I need to do new to the other side as well. Now, neither of these sides had several different terms. It was just the full left-hand side was the variable r, and the full right-hand side was that fraction. So I didn't use parentheses to grab the whole sides. Had there been plus or minus other stuff on either side that meant that there'd be more than one term, then I would have needed to use parentheses to distribute it through. Okay, so now here, 4pq over 1 times r is just 4pqr. And formulas are case sensitive, meaning that if they give you the formula with a capital letter, you want to keep writing that as the capital letter. If they give you the formula with a small case letter, you want to keep writing it with a small case letter. Now, on the right-hand side, we have the multiplication of these fractions, and I have 4 times p times q times x times y in the numerator, and in the denominator, I have 1 times 4 times p times q. Well, with all of these as being attached by multiplications, I can remove my common factors. I have a common factor pair of 4s, a common factor pair of p's, and a common factor pair of q's. So that just leaves me x times y on the right-hand side. Now, I only have the one term, the 4pqr, on the left, and I just have the one term xy on the right. So all of the terms that have my specified variable q in it, this term on the left is the only term that has the factor of q in it. The term on the right does not have a q. So all of the terms with the q are on the left side of the equation, one side, and all the not q terms are on the other side. So we're all the way down to step 4, which says to divide both sides by the coefficient of your specified variable. Well, what's multiplied to my q is 4pr. That's the step that's multiplied to my q. So I want to divide both sides by 4pr. The common factors of 4 can be removed, the common factors of p can be removed, the common factors of r can be removed. We're left with the q on the left-hand side is equal to, and on the right-hand side I don't have any common factors that I'll remove, so I have x times y over 4pr. And that is my formula solved for q.